Hello everyone, this is now question 9 from paper 1 2024, and it says the first three terms of a geometric sequence are 3 to the power of 4k minus 5, 9 to the power of 7 minus 2k, and 3 to the power of 2 times k minus 1. Where k is a constant. Using algebra and making your reasoning clear, prove that k is equal to 5 over 2. So first of all, let's see what we're going to do. First step is I've chosen to rewrite this 9 in as a power of 3. Okay, so I've chosen to rewrite this, instead of writing it as 9, I've written it as 3 squared. Okay, so therefore we've got 3 squared to the 7 minus 2k. So that is going to go to 14 minus 4k is what we're going to write there. So that just think makes it a little bit easier to work with if they've all got that same base power. Now, the key that we're going to use, such a common theme with geometric sequences, is in geometric sequences, we're going to use the idea that we have a common ratio. In other words, the second term divided by the first is equal to the third divided by the second. So u2 over u1 equals u3 over u2. So we've written all that down, and we're now going to cross multiply. Okay, so this one times this one equals this one times this one. So first of all, this one times this one is 3 to the 14 minus 4k times by 3 to the power of 14 minus 4k. And this one is equal to 3 to the 4k minus 5 times by 3 to the 2k minus 2. Let's collect our like terms now and see what that gives us. So when we collect our like terms, we find out that we get 14 add 14 is 28. Just make this a little bit more focused. There we go. Yep, so 28, and then minus 4k and minus 4k is minus 8k. And then here we have 4k add 2k is 6k, and minus 5 minus 2 is minus 7. So now we can just solve that by adding 8k across to the other side, and then adding 7 over to that side, and then we get 35 is equal to 14k, and then we just divide by 14. And 35 over 14 is 5 over 2 as required. So that's our 3 marks for part A of that question. Part B, it says, hence, find the sum to infinity of this geometric sequence. So now that we know that k is 5 over 2, we can sub that in order to get a picture for what's happening with our sequence. So we now just sub in k as 5 over 2 into each of these terms, and that simplifies quite nicely into the first term is 3 to the power 5, the second term is 9 squared, and the third term is 3 to the 7. So our first term is our a, so a is 3 to the power 5, so that is 243. Our second term is going to be, our common ratio is going to equal our second term divided by our first term. So in other words, it is this divided by this. So 9 squared over 3 to the 5, which is 81 over 243, which is a third. So we're now in a position to find our sum to infinity because we know our first term and our common ratio. So therefore, our sum to infinity is, in fact, a over 1 minus r, so 243 over 1 minus 1/3. Okay, and that is 729 over 2. And that is the answer to that one. Quite a nice question there on geometric sequences. I hope you found that helpful. See you in the next video.